Hello, for the first question for week 7A, I chose question number 10, and it states, a laser peripheral iridotomy is a procedure for treating an eye condition known as a narrow angle glaucoma, in which pressure buildup in the eye can lead to loss of vision. A neodymium YAG laser with a wavelength of 1046 nanometers is used in the procedure to punch a tiny hole in the peripheral iris, thereby relieving the pressure buildup. In one application, the laser delivers 3.5 times 10 to the negative 3 joules of energy to the iris in creating the hole. How many photons does the laser deliver? So, first of all, this is my laser right here. And then that's like the wavelength of the laser, and then that's it shooting the hole in the iris. And this little sign right here is for wavelength, and we just look at the two peaks to be able to measure one wave. So I knew for this equation I was going to use the E, and then the pH stands for a photon. Energy of a photon equals hc over wavelength. So EPH is energy of a photon. It's the ability of a photon to do work on an object. Its SI units is joules, which is just a J. And then H is Planck's constant. It's used to calculate the energy of a photon. Its SI units is joules per second, which is just J over S. And then C is the speed of light. Its SI units meters per second, just M over S. The speed of light and electromagnetic waves travel through a vacuum. And then wavelength is, this right here is wavelength of light. Its SI units is meters, just M, and it's the distance between 2 points on an adjacent wave. So that's how we calculate wavelength, is the 2 points on adjacent waves. So for this equation, I just had to plug everything in to be able to get the E, to then later get the amount of photons. So first of all, in order to use the proper wavelength, they gave me nanometers, but I know in my SI units down here that it's just meters. So I had to convert my 1064 nanometers to meters. So I divided by 10 to the 6 nanometers equals 1 meter. So divided by that, and I got 1.06 times 10 to the negative 6 meters. So now I can fill in this equation, and I fill in my H, which is my Planck's constant, which is 6.63 times 10 to the negative 34 joules per second times 3.00 times 10 to the 8 meters per second, which is speed of light. And then I have my wavelength, so I divide by my wavelength that I found up here. And then everything cancels out. My meters cancel out right here, and then my seconds cancel out, and I'm just left with joules. So that's how I get my energy for a photon equals 1.87 times 10 to the negative 19 joules. But we're not done there because they want to know how many photons does the laser deliver. So we know the total amount. They give us a total amount in here. In one application, the laser delivers 3.5 times 10 to the negative 3 joules of energy. And then we know how much energy is just one photon. So we have to divide. So our amount equals the energy total divided by the energy of one photon. So that's how we find out how many photons are actually in there. So it's 3.5 times 10 to the negative 3 joules, which is what they gave us, divided by 1.87 times 10 to the negative 19 joules, which is what we solved. And we get 1.9 times 10 to the negative, or times 10 to the positive 16. And then there is no units. I just put the pH there, but that doesn't need to be there because it's about photons. But technically there's no units. That's what I have here.